You will need a calculator for part of the quiz, and then you're definitely going to need it for your test, because solving logs and exponentials, you have to have a calculator for. You can't do by hand. So it doesn't matter if it's graphing or scientific. Either one will be fine. But we're going to talk today about an exponential function, what an exponential function is, and their graphs, okay? The two things that we're going to talk about in the next two sections are exponentials and logarithmic functions. I think I spelled that wrong. I'll show you the buttons on your calculators and stuff, but exponentials and logarithmics, these are inverses of each other. So anything that has to do with our exponential function, when I talk today about domain and range and all that, it'll be the exact opposite when we talk about logs. You can clearly tell the difference between the two of them when they are graphed and when they're written in an equation, and I'll show you that in just 1 second. But exponential function has a base, that's a number, so like the whole number 3, and the exponent is a variable. That's how you know it's an exponential function, when the exponent has a variable. So you can have 3 to the x power, that's called an exponential function. You can also have like 1/2 to the x power. That's also an exponential function. The 3 means something different than the 1/2, and we'll talk about that in a minute. We're going to talk about growths and decays. If stuff's going to get bigger in a hurry, get smaller in a hurry, that's kind of what exponential functions do. COVID was an exponential function. One person had it, then the 5 people had it, then 150,000 people had it. It grows quickly. The numbers get bigger in a hurry. So if you think about like 4 to the first power is 4. 4 squared is 16. 4 to the third power is 64. 4 to the fourth power, it gets bigger faster than if you were just like multiplying by 2 or something. The graph of an exponential function is like a smooth curve. So write that down, smooth curve. And you are going to have an asymptote. What's an asymptote again? It's a boundary. It's a horizontal, what we're going to have with our exponential functions. You have a horizontal asymptote. It's going to get really, really, really close to, but not touch. So the first part of your quiz is I'm going to give you a function. And I'm going to say, what's the y-intercept? What's the domain? What's the range? What's the horizontal asymptote? And you guys will be able to tell all of that just by looking at the function itself. I'll show you in a minute. It's really quite simple. But if you're going to use a calculator, which we will when we go on to solving in 3334, you guys need to understand how your calculator works. So make sure over the next few days you have one. But if you were going to evaluate this would be 0.5, and you would raise it. There's something called a caret button. It looks like the top of an arrow. And then that's how you would put your exponent in. Same thing here. If you had 150 and then times 2, and then you would hit that little button, and then it's negative 2.5. We'll talk more about that when you guys have calculators in front of you. But your negative sign is different than the minus sign. It's generally down by the equals. It's little. It's not as big as the minus sign, but we'll talk about that later on. Okay. This is just like the basics behind exponential functions, all of our characteristics. One of the most important things to remember is the domain of all of your exponential functions is what? Negative infinity to positive infinity. It's just like our parabola. Every single time you have an exponential function and they say, what's the domain? Your answer is negative infinity to positive infinity. We'll talk about y-intercepts, where the graph crosses the y, where the horizontal asymptote is that gets really close to but doesn't touch. But look at these two graphs. These are both exponential functions. If you were to read it from left to right, the blue one is going what direction? Up. And the red one is going which direction? Down. The blue one is called a growth. It's getting bigger. Here's your growth. The red one is called a decay because it's doing what? Getting down, going smaller. So then you can also tell, not only by looking at the graph, but you can tell if I said this is this graph, and if I said this one is that graph. Look at the bases. What do you notice about the base of the red versus the base of the blue? The base is the parenthesis, okay? So what do you notice about the number in red versus the number in blue? A fraction, okay? Your decays are going to be between 0 and 1. Not necessarily like 3 over 2. Obviously, that's bigger than 1. But if you have an exponential decay, your growth factor, they call that, will be between 0 and 1. And if your base is a whole number bigger than 1, then it's going to be a growth. Okay, so let's just talk about some things here. Look, do you notice these two functions? 3 to the x power. Is this a decay or a growth? They're both growths. What do you notice is different? There's a negative sign in the exponent. All right, we're going to talk about what different things in each equation mean. Anytime you have a negative sign in a function, what does it do to the graph? Flips it. Good. Whether it's out in front, it flips over x. If it's in the exponent, it flips over the y. Okay, just some things that will help you when you are graphing and recognizing graphs, like on WebAssign and stuff like that. I'm not going to go through all of this. If you guys wanted to graph this, how would you figure out what points were? You'd plug in values for what? X, and then you get out a y, make an XY chart. What I want to get to is being able to, do you see the two graphs here? F of x is a what? Decay or growth? F of x, oh, they're both f of x. I didn't realize that. Blue is what? A decay, good. What's red? Perfect, good. All right, so let's get to the thing I want to talk about here. Okay, here's where I want you guys to pay attention. I know there's lots of words here, but we already know what this means. If you have a vertical translation, which way is vertical? Up and down or left and right? Up and down. So vertical translation means your graph moves up or down. Where does that occur in the actual equation? It's your plus and minus at the end. So if you had something and at the end it said plus 6, that means the graph moves where? Up 6. If it says minus 3, that means the graph moves where? Down 3. Your vertical translation is your horizontal asymptote. Every time. If there's nothing there, nothing added or subtracted, then your horizontal asymptote's at 0. We'll talk more about that in a minute. Think about horizontal. Which way is horizontal? Left and right. So you guys should have talked about this in Algebra 2. Notice where left and right transformations occur. It's inside the exponent. So if you have a vertical, if it's going up, it's going to be plus. If it's going down, it's going to be minus. So anybody remember what happens when you move left and right? Left is, well, is it plus or minus? It's plus. It's the opposite of what you think. It's always the opposite. So if it's a plus, then it's going to be moving left. And if it's a minus, it's going to be moving right. Anything horizontally is the opposite of what you would think it is. Vertical, if it says plus, it goes up. If it says minus, it goes down. If it is in the exponent, it's horizontal, it's going to do the opposite. So let's talk about reflections, flipping. If you have a negative sign in front of your function, what does that flip over, the x or the y? Think about our parabolas. If it's positive, it's going up. If it's negative, it's going down. Where is the negative sign? Is it out in front or is it somewhere in the middle? It's out in front. So if you have a negative sign out in front of your function, it's going to flip over the x. If you have a negative sign inside your exponent, it's going to go over y. And you guys are like, why does this really matter? You'll see on WebAssign when you're trying to like pick different graphs and stuff like that. The vertical stretching and shrinking, we don't get into much. But again, vertical's out in front. Horizontal is going to be with the exponent. So why does this matter? Okay, let's talk about g of x. Okay, I'm looking at g of x. We're going to graph it. I don't like this graph. I'm going to move. Don't mind me. I'm moving the x-axis right here. So this is going to be 1, 2, 3, 4, 5, 6, and 7. This is -1 down here. See what I did? All right, so on your quiz, when you have it next week, they're going to give you a function that looks like this. similar to this. And it's going to say, tell me the domain, the range, your horizontal asymptote, your y-intercept. Might even ask you for a vertical asymptote. All right, well, right away, you can tell me the domain. What's your domain of every exponential function? Negative infinity to positive infinity. Now, I told you to find your horizontal asymptote, and your horizontal asymptote is going to go hand in hand with your range. Your horizontal asymptote, where the graph gets really, really, really close to but doesn't touch, is your vertical shift. So where is my horizontal asymptote at? 3. Y equals 3. So you would go to 3 and you draw a little boundary line here. So that means my smooth curve is going to get real close to that line but not touch it. So now we have to figure out if it's going to be above that red line or below the red line. Well, let's figure out where this graph crosses the y-axis. How would we figure that out? I have y equals 4 to the x power plus 3. Very good, Coy. How do you figure out x or y-intercept? You plug in 0 for what? Okay. So 4 to the 0 power plus 3. What's 4 to the 0 power? 1, and 1 plus 3 is 4. So your graph is going to cross at 0, 4. So your y-intercept is at 0, 4. So it's right there. So let's think about this, guys. Without finding any other points, you can plug in -2 and +2, but if we want to get a general picture of our graph, it's going to be a smooth curve. Is it going up or down? It's going up because my whole number is, the base is whole number +4. So I know it's going to be going up, and it's going to cross through where y is 4. It's not going to touch the horizontal asymptote. So it's going to be generally like this. It's going to get close to that asymptote. It's going to go through here and go up. As long as you know your horizontal asymptote and then your y-intercept, you can tell everything else about this graph. Now it's going to ask for the range. And you guys are like, oh, well, I have two options. It's either negative infinity to your horizontal asymptote. It's just like a parabola. Or it's your horizontal asymptote to positive infinity. Where does this graph exist? In between negative infinity and your horizontal asymptote? Or from the asymptote to infinity? Where's the green smooth curve? From 3 to infinity. Does it include 3? No, it's going to get really, really close to 3, but never what? Never touch it. Good. So the first question on your quiz is going to be something just like that. The only thing mathematical you really have to do is plug in 0 to find out where it crosses. So the question of a vertical asymptote, if this has negative infinity, positive infinity, it's going to continue to get wider in both directions, right? Does it have a vertical asymptote? Is there a boundary line vertically that this is going to get really close to and not touch? No. The answer is none for vertical. So in 2 days, when we talk about our logarithmic functions, they're inverses of each other. So in that case, think about it. If our domain in exponential is negative infinity to positive infinity, but then we're going to talk about the inverse, what do you think changes? No. What do you think is going to change? Instead of domain, it's going to be what? Is negative infinity to positive infinity? Range. Instead of having a horizontal asymptote, what do you think we're going to have? A vertical asymptote. Instead of having a y-intercept, what do you think we're going to have? An x-intercept. It's just the exact opposite. Yes, sir?
So does that mean that exponential functions can't have vertical asymptotes?
Correct. Exponentials will never have vertical asymptotes. Logarithm will never have horizontal. They cannot coexist together. But it's really a quite simple concept. It really is, I promise. All right, let's look at f of x and g of x. Let's just talk about it. What's the domain for both of these? Negative infinity to positive infinity. Good. What is the horizontal asymptote for both of them? What are you adding and subtracting at the very end? Nothing. So what's your horizontal asymptote? Y equals 0. Where does this graph move? Does this graph move up or down? No, it's moving which way? Left and right. So if it's on the x-axis, it's the opposite of what we think. So this way, it's moving which way? Right too. Good. How would you find the y-intercept? Plug in 0 for x. So it's 4 to the negative 2. You guys are like, what? How do you make a negative exponent positive? Turn it to a fraction. Good. So where does this cross the y-axis? At 1/16. Do we know exactly where that is? No, but we know it's a little bit above what? 0. Right? So if this is your asymptote, then it's going to be like, boop, right there. Just a little bit above it. But it's really, really, really not terribly difficult. Now we get to this. You're like, seriously? Does anybody have a calculator on you? Handy? If you look at your calculator, there's an ln button. That's natural log. If you look at ln, e to the x is on that same button. If you hit e to the x, like if you hit it, the e will come up. It's programmed in your calculator. It's like pi. If you hit pi, it's 3.1415. E is a special value that is programmed in your calculator already. So you wouldn't be expected to figure this out by hand. But you can tell me, like, where's the horizontal asymptote? What's being added or subtracted right there? Nothing. So your horizontal asymptote's at y equals 0. What's your domain? Negative infinity to positive infinity. Good. What's your vertical asymptote? There isn't one. Good. How would you figure out what your y-intercept was? You'd plug in 0 right here. So this is where you would have to say in your calculator 4, and then you hit E, and a little button will come up, and then you put a 2. And it'll give you some wackadoodle decimal. But again, anything that has the E function, you're always going to use your calculator. When we go to solving, you have to have a calculator because you can't do this kind of stuff in your head. So if I gave you, let's just say, we'll do one little example. F of x equals 1/2 4 to the x minus 3. Okay, we're going to find domain, range, vertical asymptote, horizontal asymptote, y-intercept. What's my domain? Perfect. Negative infinity to positive infinity. What is my vertical asymptote? There is not one. Don't get tricked on that. What's your horizontal asymptote?
Why is there no vertical?
If exponential never will have a vertical. It always has horizontal. Log will be the exact opposite. It'll never have horizontal, it'll always have a vertical. Because if your domain is forever getting wider on both ends, there's never going to be like a vertical spot on the graph where the graph doesn't exist. What's your horizontal asymptote for this one? Y equals -3. Okay. So you know your graph is going to get real close to -3, but not touch it. Does this flip over any axis? Do you see any negatives in front of your function that makes it flip or anything? No. Is this a growth or a decay? It's a growth, so you know it's going to be a smooth curve going up. So let's figure out where it's going to cross the y-axis. You can already tell me what the range is, but it might be helpful to find the y-intercept. How do I find the y-intercept? Plug in 0. Okay, so 1/2 times 4 to the 0 power minus 3. Here's the hardest part of your day right now. What is 4 to the 0 power? 1. So 1/2 times 1 is 1/2 minus 3 over 1. Can we do this? If I change 3 over 1 to seconds, what does that become? 6 over 2. Good. So what's 1 minus 6? -5 over 2. So this graph is going to cross the y-axis at 0, -5 over 2. Do we know exactly where that is? Yeah. -5 over 2. That's -2.5, right? So like right here. So draw a nice smooth curve. Oh, that's cute. Nice smooth curve. Okay, we've answered everything except for the range. So there's only two options for range. It's either negative infinity to the horizontal asymptote or the horizontal asymptote to infinity. Where does this graph exist? From negative infinity to the dotted line or from the dotted line to infinity? From negative 3 to infinity. And does it include, does it ever touch negative 3? No. So there you go. Now, how would you find all the other points if you needed to? You can plug in negative 2, negative 1, 0. You could do all that to find exact points, but we're not looking for that. I need you guys to be able to identify where it crosses the y-axis and where it exists. Is it above the asymptote or below? And then you can tell the range and all that. Sound good? All right, we'll do like the equation-y kind of things tomorrow along with interest problems.